This is to give you an overview of the thinking that you need to put in place when you have any kind of condition. It's up to the patients, and you have to realize this.
The premier source of patient-centered information on PKD and how to reverse it. This is Felix Mueller.
Hello everybody, this is Felix, your favorite friendly neighborhood kidney hacker, coming back today for episode number 9. Today we're going to address how to think if you have a genetic or otherwise incurable disease where everybody keeps telling you there's nothing that you can do. So I just want to take you through sort of the thought process that I had when I found the first hint that this dietary approach could be something that works for PKD. And I want to show you how you can apply the same sort of thinking to any kind of genetic disease or even other quote-unquote incurable condition, right? I was very lucky in that I found this first hint that keto was going to work for PKD by accident. Many of the big inventions were actually come upon by accident, right? So in my case, I just started the Bulletproof Diet because of different reasons. And then I sort of suspected that something might have improved just because it improves so many things if you eat the right way. And then I went to my next MRI and I found out that it actually had improved. In this case, by 7% over a period of 3 years. I was very lucky to have done an MRI before that so that I even had the comparison. That was also a lucky accident. So sometimes good accidents happen. In your case, you might not have that hint, right? So if you don't have PKD, you have something else, then you might not have that hint that gives you sort of hope and the idea in which direction you should be looking. Where do you start, right? You have a genetic disease, you have an incurable condition, and then you start looking around the internet and the published science. So you can access the published science at PubMed, right? It's a completely free database of papers and everybody can go into it, and I will link it below, right? You start looking at the penetrance of your condition. So for example, in the case of PKD, people usually just get diagnosed with PKD when they have symptoms, cysts in the kidneys, right? So they get an ultrasound and they sort of stumble upon these cysts, and then maybe they get a genetic test later and they found out, wow, I have PKD, and they find the gene. What if we did a larger population-wide sequencing study looking for the gene for PKD and seeing if that number differs from what we would expect based on imaging? We would expect about 10 out of 10,000 people to have PKD. Now, there actually was a population-wide sequencing study looking for the PKD gene. And what they found is that actually 20 out of 10,000 people had one of the genes. Maybe, just maybe, the PKD gene is not 100% penetrant, is what they call it, right? So not 100% of the people that have the gene get symptoms. Now, this will blow the minds of most PKD patients, right? Because they've never thought about it that way. In the case of PKD, we don't know for sure because they did not go in and ask these 20 people if they had gotten ultrasounds or MRIs to see if they had cysts. We can imagine that there might be some in there that maybe don't have cysts or just very little, or, that's sort of a sliding scale, and maybe some of them don't even have any cysts. Something else that you can look at if you have a predetermined condition is how it changes over time, right? So there are some genetic conditions that you can't even be born with because they are so dire that your whole system doesn't work and you can't even sustain yourself as an infant, right? But some conditions, also in PKD, get worse over time. And in the beginning, they might even not be there. In PKD, it's like, there are many people that don't have cysts until 6, 7, 10 years old, right? Maybe even older than that. So that also gives us a hint, right? If it's genetic, and if it's always the same, like they say, right? It can't be that you have 10 years of your life where it's not affecting you because the gene is always there. So what's happening there? Is there a difference in how the gene is being used or what the demand is on the gene, right? Maybe as a child, the rest of your body just takes some of the load away from what the gene has to do, or the system is just more tolerant to failures. So if you're either able to find that the gene or the condition that you diagnose with is not 100% penetrant, so not everybody that has the gene has these symptoms, or that the symptoms just start getting worse over time, but there's a period where there's not really any symptoms, Those are your hints. Something is different than you might have thought beforehand. If it's a predetermined condition and everything's just going to turn out the same, then that wouldn't be possible. So now you have to dig a little deeper, read some of the studies, look for the name of your condition, put in PubMed, and you search for papers that give you pause, where you think, how is this possible? So look for papers where there might be other factors involved. Again, PKD. One of the papers that gave me huge pause was a paper where they had a population of mice that had a similar gene that also produced PKD in mice. Of course, they don't have the same gene because they're not humans. And then they had one population of these mice that they bred without gut flora. So they call them germ-free mice, right? So they have no gut bacteria and probably also no bacteria in other places in their body, at least mostly. Nothing's perfect, I guess. So in these mouse populations, 96% of them did not have any cysts. How is that possible, right? You have a genetic condition. The mouse has a genetic condition and they don't have cysts. How does that compute, right? So then you go deeper. There's a couple of potential mechanisms. All of them, of course, related to gut flora. Probably gut bacteria, but there's also viruses and fungi in the gut, right? So you're not 100% sure what it is. But something in the gut is either migrating to somewhere that's influencing the kidneys, or is producing something that's migrating somewhere to go to the kidneys, or the stuff that's already migrated to the kidneys is causing issues there, or it's producing toxins there, right? So you don't know if the bacteria or fungi are producing metabolites in the gut that are traveling to the kidney and sort of causing something there, or if it's the bacteria or fungi themselves that travel there. And you also don't know if the effect that they have on the condition is in the gut or in the kidney, right? Because that's the distance that they have to cross. It's also possible that, in theory, that there could be gut bacteria that should be staying in the gut because the gut lining is tight and closed. And now that they have PKD and the bacteria, then the gut lining opens a little bit and they can get through and cause havoc in the kidney. Now you think a step further. And now you ask yourself, okay, what about transplant patients, right? They still have the mutation, at least they have it in the gut, right? Because the PKD genes are also expressed there. It's another thing that you have to consider, right? Where is the gene actually expressed? Is it just in the area that has the symptoms, or is it also expressed somewhere else? And you can find this information usually in the research. So in the case of PKD, it's also expressed in the gut lining. If you get a transplant, if it's just about the gut lining, you would expect the transplanted kidney to also get cysts because same stuff's going to get through, same stuff's going to get filtered. Usually they don't get cysts. There's some very rare cases where they do, but these things are difficult. But if you go by 99% of cases, there's no cysts in the transplanted kidneys. How does that work, right? So maybe it's both, right? Maybe in PKD, the tight junctions, they are affected, right? It's in the literature. They let something through, and then also at the site of the cysts in the kidney is just less able to process this, whatever's coming through, right? The transplanted kidney is more able to process this. And so it doesn't cause a cyst over there. So these are the hints, right? So now you start to form your first hypothesis, which could be there's some toxin or some bacteria that's produced in the gut that's sort of traveling through the bloodstream, ending up somewhere also in the kidney. And then the mutated cells can't really handle it. And that's why they become cystic. Remember, the body's not stupid. It's not like the body just forgets to do something. It's not like the body just starts making cysts because it forgot how to make a healthy kidney. It didn't forget anything. Why could it be that the body makes a cyst? What is a cyst? There's usually stuff inside the cyst fluid that is a problem. So why does the body make a cyst? Well, for some reason, it can't remove the stuff in another way. It's just like you get when you get boils on your skin when you get an infection, right? The body puts it into this cyst to get rid of it or to disinfect it in there, right? To isolate it and then deal with it. In the case of PKD, it doesn't seem that the body is able to deal with it. So it just stays there. It just gets encapsulated and the body can't process it any further. Likely because its detox mechanisms are occupied with something else, or they're weakened so much by the mutation that they can't do their job. So there's your hypothesis. Now you can test the hypothesis and maybe you can find other studies, maybe in other conditions, that sort of give you another hint, if that is a hypothesis that would make sense. So in the case of PKD, you look for studies that analyze the cyst fluid, that give you more clues about, what is in there, right? And there are studies doing that. And they look at the content of the cyst fluid and they find out that if you pull out the cyst fluid of the cyst and you put it somewhere else that doesn't have PKD, so any standard kidney tissues that doesn't have PKD, and you put the cyst fluid on that tissue, it will grow a cyst. So what does that tell you about the hypothesis? Makes the hypothesis more likely, doesn't it? So for some reason, this disease seems to be accumulating toxins that maybe shouldn't even be there because the gut should be keeping them out of the bloodstream. And it can't deal with them. And that's why it puts them into that cyst. So now you can already see which kind of interventions you might be thinking about researching next, also working maybe in other conditions that might ameliorate, mitigate these issues, right? So first line of defense is the gut lining, right? Are you doing everything for your gut lining to keep out the toxins out of your bloodstream? If you're not doing that, even though you might have a mutation, you can have on top of that more issues that make the gut lining weaker. So you want to make sure that you are doing the strategies that are known to strengthen the gut lining. Maybe even the 50% we might suspect that have the gene but don't have cysts, maybe they just have a stronger gut lining. Maybe that's already it. We don't know. We have to do these tests, but sadly, this kind of systemic thinking is not very present in patients and even in researchers because they are very, very focused on single things and very few take a step back to look at these approaches and look at the broader picture, which I'm painting here, right? Maybe some researcher will see this and craft a study that's based on this hypothesis. So now you could start looking into what are the things that are accumulated in the cyst fluid that make it grow a cyst. What are, in general, toxins that can grow a cyst? Can bacteria grow a cyst? Which toxins are there in the bacteria that can grow a cyst? And in the case of cysts throughout the body, if you do some more research, you will find that there is something called endotoxin that is made by, you guessed it, bacteria. And endotoxin is very prone to triggering cyst growth. And there's even a study where they tried to make PKD cells grow a cyst, and it didn't work with injuring the cells until they added endotoxin, bacterial toxin produced by bacteria in the gut, likely. So endotoxin, huh? Did they find it in the cyst fluid? Yeah, they did. Not in all of it, but in a large portion. And we're not saying it can only be endotoxin. There's also other bacterial toxins, right, that the gram-positive bacteria make. So endotoxin is made by gram-negative bacteria, but gram-positive bacteria also make their own toxin. Exotoxin, right? So maybe that's involved as well in the cases where endotoxin was not found, or even in both cases, right? So what's the next question? The next question you could ask is, what does the body do usually to mitigate endotoxin? And then you'd start some research. You look at other conditions. Again, like you try to find the parallels between your condition and other conditions that have been maybe more researched. In the case of PKD, there's a lot of parallels with cancer, actually, which we can also get into. One of the enzymes that binds endotoxin in the body is called argininosuccinate synthase. It's an enzyme that makes argininosuccinate, right? So this enzyme is usually used for something else, but it can also bind endotoxin, and it does bind endotoxin as soon as it is in the blood. Then you look at PKD, and argininosuccinate synthase. Just look what you find, right? You just put the two, put in Google, put in PubMed, and find out what is there in the research. And in this case, there's a study showing that rats with the PKD similar genes, they will have 90% reduced argininosuccinate by a couple weeks of age, right? So very, very early on, argininosuccinate is almost completely gone. Wow. So how's that possible? Maybe there's endotoxin in the blood, right? Now you have a hypothesis. Of course, you don't do this in a day, right? It took me months. And you can go down all sorts of rabbit holes. And you have to dig your own rabbit hole into the research, right? Because you are starting to find the parallels. And you have to realize there's no doctor out there that will do this for you. And there's no scientists out there that have the assignment of doing this. There's nobody out there for your disease that's putting these things together. There's nobody doing it. I mean, you might think that there's people doing this all day. Maybe there should be, actually, but there's not. And that is a great opportunity for people that are interested, that are patients themselves, to start digging into the research and publish about it. And then even, start up GoFundMe or whatever and get some funding from other patients. So you can do this maybe full time, right? It's what I'm starting to do because I think this is really something where there's a lot of potential and we can find out so much more just by seeing the parallels. And right now there's nobody doing it for most diseases. So it's up to the patients. And you have to realize this. You are the people that are interested the most in doing this work because you are affected. You're motivated by something other than money. You're motivated by your life, right? It's everything. But most people, they just write it off, somebody else is doing it. They're more qualified than me. So it's not even worth spending my time. I can just go back to work or, to the cinema and do whatever. No, it's about you. You have to be the people that do the research, read the research, and then find the parallels and start testing stuff. Because most people, they aren't trying stuff. They just live their lives as if nothing could be done, and nothing could be farther from the truth. So, all right, there's a hypothesis. Endotoxin might be causing the cysts, right? There's a lot of hints pointing in that direction. So you could just start and look at things that you can do to mitigate endotoxin. In this case, there's probiotics. There is trace mineral supplements that are supposed to tighten the gut lining. You can supplement certain things to increase your argininosuccinate synthase, like citrulline. And then there's also things that you can do to strengthen the response of your cells to endotoxin. So, for example, MCT oil, ketogenic diet, right? Those will improve your resilience to endotoxin. Many people on this channel will, of course, now ask, okay, but isn't PKD all about ketogenic diet and sugar? Where's the connection there? So in PKD, this mutation seems to, and this is very early research, it seems to lower the capability of the cell to make energy because it inhibits the flow of calcium into the cell. This means that the cell is less capable of dealing with certain injuries and offenses. For example, endotoxin, right? As soon as the cell is overwhelmed, or as soon as for some other reason the cell says, wow, this is too much for me, then it switches over its metabolism from the normal respiration, like breathing oxygen for making energy, like it takes glucose, takes oxygen, combines the two, makes a lot of energy. That's the normal thing that works. And we've talked about this in other videos, right? If you haven't seen this, you should look at my first episode, which goes into more of the basics of PKD. So this mode of producing energy is the standard, right? In this mode, we don't have any cyst growth. But for some reason, this cystic cell has decided that it cannot make energy using oxygen anymore. Maybe because it's trying to oxidize the endotoxin. It's trying to use the oxygen for something else, not for making energy, because it prioritized oxidizing the endotoxin to make it less damaging. Maybe the influx is just too large, or the cell does not succeed at this. But in any case, it seems to be using the oxygen, maybe, for something else. Maybe a pathogen like a bacteria that's making the endotoxin is telling the cell, don't use the oxygen for energy production, just use the other mode of energy production, or the cell is deciding itself that it needs the oxygen to make reactive oxygen species to kill whatever is invading the cell. Maybe endotoxin, maybe bacteria, maybe fungi. But for now, it looks like it's endotoxin. But I'm always willing to be convinced of something else. We have to abandon this mindset that the cell has sort of lost its way and it doesn't know what to do. Probably if the cell were to use the oxygen for making energy, it might even get worse, right? Maybe if it stops to use the oxygen to try to deactivate whatever pathogen is in there, maybe you would get even worse. You don't know. Maybe if you stopped the ability for the cell to make a cyst, you would get sepsis. Maybe there's stuff in there that just can't be detoxed. And if it can't be detoxed and can't be excreted in the urine, then it might just stay in the bloodstream. And then you might need dialysis at, 14 years old. So the cysts might just very, very likely be something that's actually protecting us. Because if we didn't have them, then our bodies might just not be able to work at all because they're so toxic, because something else is going on. So back to the keto connection. Now, for some reason, the cell in PKD decides to go back to this different mode of energy production, right? Which is not respiration, but it's fermentation. So it takes the glucose and it makes energy out of that without going to the mitochondria. The mitochondria are the little energy factories inside the cells. They are ancient bacteria, interesting, which have sort of, capitalized on our cells and they live in there. And they help us make our energy and they're very, very important for us, right? If they stop working, we'd be dead. And they do stop working, right? And that's why people die. That is one of the causes of death in old age. Mitochondrial function is basically non-existent in these PKD cells. Maybe because the cell decides to switch them off, but under the electron microscope, it looks like these mitochondria are actually deformed. So they're not working anymore, or just very inefficiently. Then there's the next question, like how does that happen? Does that just happen because they are getting too little calcium from the mutation? Or is it something else? Is it the endotoxin? Is it something else, some other bacteria that's sort of trying to destroy the mitochondria? So the cell has decided for this or the other reason to forego its oxygen or to use the oxygen to make free radicals. And now it is making energy just with glucose, ferments it and produces a lot of lactic acid as a byproduct, which is similar to what you're feeling when you do a lot of strength training, a lot of running without adequate rest, which is, this burning feeling in the muscle, right? That's lactic acid. And that's how the muscle makes energy if you are overexerting it, right? Now that we are in this inefficient mode of energy production, that is where the ketogenic diet and ketosis attack, right? They are not fueling this inefficient mode of energy production. So they are trying to force the cell to either die or switch back to using oxygen for energy production. And both of these likely happen, but switching back to using oxygen is also robbing the cell of this option of fighting the intruder with building free radicals. So do we really want to do this? Hard to say, but it looks like it has benefit. The other option of the cell just dying when you deprive it of the right energy source, which is glucose, right, by giving it more ketones, which it can't use for this. So if it's not able to switch back to aerobic respiration, now it has to die. This really shows us that once you start to build a larger understanding of the disease, that multiple areas of attacking the disease or of helping your body to better cope with the issues that it has emerge, right? So in this case, you can try and limit the exposure to endotoxin. You can try and increase your body's capability of handling it. And you can also start and take the nutrients away for the pathogenic process that is caused by the endotoxin. And there might be many other ways to do it, right? There's other supplements that they upregulate autophagy or even apoptosis, which means cells are getting eaten for their protein content, so the proteins can be used somewhere else. So this is another mechanism that might be at play here, which we have some research for. We can even draw parallels to cancer in both of these avenues, right? So the toxin that sort of aggravates the disease, and then also the metabolism that is triggered by the toxin, maybe, that we can also attack, right? So there's a great book by Mark Lintern, and it's called The Cancer Resolution. I recently started reading this very fascinating book. And he has found that there is a fungal pathogen involved in cancer, and very likely in all cancers. And it's a new emerging cancer theory, called the cell suppression theory, which I will link below as well. And he's saying that fungi, also from the gut, migrate somewhere in the body and they hijack cells and make them stop using respiration, because the fungus gets better access to nutrients when the cells just go into this fermentation mode, which replicates the cell a lot and also doesn't use oxygen, right? Interestingly, in cancer, now there's also two ways in this hypothesis, which does seem very, very interesting, to attack the growth, right? You can attack the pathogen, which is the fungus, right, with antifungal medication and, of course, a whole array of therapies, which has to be done by a qualified practitioner because you don't want to hurt yourself, which is very easy. So in some people, they're so far gone that even putting them on antifungus medications, antibiotics, can be a problem for their overall health. So maybe some people aren't even able to withstand the therapy, similar to chemo, right? So of course, can't just go around taking antifungals without proper medical supervision. But in this case, it's antifungals, but also metabolic therapies, right? Taking the fuel away for the cancerous cells. In cancer, of course, it's a bit different than in PKD, because if you just remove the cancerous cells, there's no cyst fluid that's now going to be somewhere and probably cause new issues, right? If the cells are gone, they're gone. But we can see that in cancer, if it's properly therapeutically addressed under this paradigm, the cells can actually go away. And even just with the metabolic therapies. So if you just get the body to stop fueling this malicious growth, there are cases of it completely resolving the tumor, which means that once we sort of attack these cells in the right way, when the body gobbles up these killed cells, it also sort of destroys the cell contents, even if it's pathogenic. So that is very good news for us, even in PKD, right? However, in PKD, we don't know what happens when you would be able to do this and you would be able to just kill off the whole cyst. What happens with the cyst fluid, right? We don't know. So that's another thing that we have to research. What happens if a cyst bursts? Well, we know that you get blood in the urine. You know, you might get a UTI. You know, there might be some extra infection, but it might also cause new cyst growths. So also, if you get a cyst aspired and they remove the cyst fluid, there's a risk of them dripping some cyst fluid somewhere else, which then might cause new cyst growth. So very, very important. So this is sort of to give you an overview of the thinking that you need to put in place when you have any kind of condition where you're not sure if you can do anything about it. And this is how you find out, right? You find your first hint by looking at the penetrance of the gene or the condition that you have. Like, does everybody get the same symptoms? When do they start? How severe are they? What's the variation? And then what can you do to be in the population that has no symptoms or almost no symptoms? And what's the difference between those? Start finding out what are the aggravating and contributing factors to a bad disease outcome. Another option is to look at how it progresses over time, right? Does it start when you're a kid? Does it start when you're an adult? And what is the difference between the body of a kid and the body of an adult? And why might that impact the quote-unquote incurable condition that you have? And then you start sort of digging through the available research, trying to find things that stick out. Like in the case of PKD, it was the mouse study where you just leave the bacteria out and for some reason, then you don't get any cysts almost. It sticks out like a sore thumb. You think, what? Why didn't I know about this? Why haven't I read about this? Why is this not researched further? Well, the answer is, of course, that there's not a lot of money in like gut flora remediation. But in PKD, you might even find somebody that doesn't have cysts, but has a great gut flora, and you get a fecal transplant from the guy, and then you might be cyst-free. We don't know, right? We don't know. It's just a hypothesis. So you dig through the research, PubMed, right? You get from one study to the next, read the references. Maybe there's something else interesting in there. You find some study that gives you pause, where you think, wow, how does that even work? Like you can just start by looking at natural interventions that have a positive impact, and then try and see what is the mechanism of action there. Look at some of them, and maybe at some point you think, wow, this is really interesting. And then you look at other diseases where the same mechanism is implied that you think might be a play in your condition. Like in PKD, the mitochondrial issues are very much in parallel with cancer. And in cancer, there's like a million times more studies, right? So there's a lot of cancer studies that I read to learn more about the mechanisms of PKD, and it does seem to transfer, right? Because it's the same pathology. It's the same thing that happens after the cell starts to replicate that much. And then once you have that, then you can sort of start to form a hypothesis, and you can start to look at things that you can dream up that might be able to impact that mechanism that you hypothesize, that maybe other scientists have hypothesized already. And then you start putting it all together. You know, if you don't know what works, just do many things at once, and you might soon find out that there's something that works. I believe that in many, many cases, some kind of infection that hasn't been diagnosed is at the root of so many issues. But it can also be other forms of toxins, right? Heavy metals, bacteria, fungi, some other weird substances that are in some injections that some people get. Things that irritate the immune system, that make it impossible for it to do its work properly. Things that lower mitochondrial function. All of these can be relevant if you're trying to look at what's really at play in your incurable condition. If you have other questions on how to think about this, if I missed something in this video, just drop me a comment below. Please give me a thumbs up and subscribe to this channel. Help other people find it by growing the number of subscribers, because I think it's very relevant to many, many people, even beyond PKD, at least in this video. And really go out there with a new sense of hope, because there's so much that we don't know about how biology works. And it's not like it can only be done by scientists in some lab and you have no control, right? Because there has been science for a very long time and nobody's taking the time to look at all of this. But you can take the time to look at the science in your area of interest, and you can start putting things together and learning about it and telling other people about what you found. In my case, I just founded a Facebook group because on the Facebook groups that I was already on, people were thinking I was crazy. So that's why I made my own group. And now we're approaching 6,000 members, which is great. Of course, we want to grow a lot more. And we want to have free discourse. We want to be able to talk about these things. We want to be able to share studies. We want to be able to discuss and find the issues that are plaguing us, right? And trying to find solutions to that. So I hope this inspired you. If you have some condition that people have told you until now that you can do nothing about, please go ahead, look at the studies, start finding your first hint, maybe that there's something that you can do, and dig your own rabbit hole through the research, right? Do what the medical establishment is not doing. They're not doing the deep research for your condition because they're not interested in that way. They're not affected personally. They have a 9-to-5 and they're searching for some very specific things that they can sell you later on, right? But you want to find the 30,000 foot view of your condition and find what works. So I hope you enjoyed this video. I hope it helps you improve whatever condition you may have. If you do have PKD and you do want some more personal help, then you can always visit me at reversingpkd.com and book a free 15-minute call so we can see if personal coaching, health coaching is the right thing for you. Or you can also join our Facebook community or our community on MeWe if you want some more discourse with other people who are trying to tackle this with diet and lifestyle and the right supplements and are very successful at it. So until the next video, happy healing.